Introduction to Silego's HFET products. Silego's high-performance IPSs have many advantages. Among them, proprietary copper FET technology, greater flexibility in power sequencing, multiple built-in system-level protection circuits, logic-level turn-on signal, open-drain fault signaling, open-drain power good signaling, analog current monitor output, UL certification. Part 1 of Silego's two-part proprietary copper FET IP is the construction of the IPS itself, using a 180 nanometer standard foundry CMOS process. As shown in this graphic of the IC's cross-section, a Silego IPS is constructed of a control circuit on the right and a FET array on the left. The low RDS(on) FET is constructed of many octagonal FET cells, all connected in parallel using the process's multiple low-resistant interconnections and metal layers. Since the RDS(on) of each FET cell can range from 2 to 6 kiloohms, the parallel connection forms the FET array. For example, if a 20 milliohm unfed RDS(on) is desired, then as many as 100K cells are wired in parallel. Using this vertical interconnect and distributed FET structure, Silego can design an IPS to operate with a continuous current rating from 1 to 10 amps. Part 2 of Silego's copper FET IP is in the construction of the IPS IC into an encapsulated package. The vertical construction of the IPS IC is mated to the copper lead frame using copper pillars, where the control circuit, power supply pin, ground pin, and drain source FET terminals can be accessed. As shown in the scanning electron microscope cross-section of an actual 1 by 1.6 mm unfed IPS, the IPS IC is mounted upside down or flip chip. Please note that the plastic encapsulant surrounds completely the IC, providing additional protection. This is a typical block diagram of a self-powered HFET IPS. An internal charge pump is used to provide enough voltage drive to fully enhance the power N-channel MOSFET. Linear ramp control, together with an external capacitor connected to CAM pin, is used to provide linear output voltage at the source pin of power MOSFET. Also, this circuit provides inrush current limit during power-up operation. An internal overcurrent and overtemperature protection circuit is used to protect the device from overload and overheat. An internal discharge circuit helps to discharge output capacitors connected to the source pin once the device is toggled off. An internal analog current monitor output is used for power rail output current or power measurements. In addition, Silego's IPSs have an internal overvoltage protection feature. By the use of external pins at cell 0 and cell 1, the overvoltage protection threshold voltage can be easily adjusted. To illustrate HFET1's internal SOA protection to overcurrent events, one observes that when current limit protection is triggered, the IPS's fault output becomes asserted. The IPS will continue to operate in current limit until its internal die temperature crosses the IPS thermal shutdown threshold, where it is then turned off internally. When the die cools, IPS operation automatically restarts, and if the IPS remains in current limit, its thermal protection remains activated until the IPS is toggled off or the overload condition no longer persists as shown here. Additionally, all Silego HFET1 products have internal FET safe operating area, or SOA protection, that serves to protect the FET from damage. When current limit protection is triggered, the IPS's fault output becomes asserted. So long as the IPS's internal junction temperature remains below its thermal shutdown threshold, the IPS will continue to operate in current limit until package power dissipation exceeds the IPS's internal 5 watts SOA threshold. Once the SOA protection threshold is triggered, the IPS will shut down and automatically restart until the IPS is toggled off or the overload condition no longer persists as shown here. Illustrated in this slide is a typical power-up operation of a high-power IPS or hot swap controller without internal SOA protection. During power-up into heavy capacitive or resistive loads, the RDS(on) is high, and thus package power dissipation increases quickly. Using the device in this mode for extended periods is not desirable, because its reliability may degrade quickly and possibly suffer damage. That's why all Silego's HFET1 IPSs have internal SOA protection feature that shuts down the IPS if package power dissipation exceeds 5 watts for more than 2.5 milliseconds. All HFET1 products automatically retry to power up after every 160 milliseconds until the overload condition no longer persists. Some part numbers have an increased maximum SOA power threshold to 15 watts to allow power up into heavy resistive and capacitive loads. Illustrated in this slide is a scope shot of HFET1's SOA protection scheme as the IPS is powering up into heavy resistive load. Since package power dissipation is higher than this IPS 5 watts SOA threshold, SOA protection becomes activated and the IPS is switched on indefinitely until overload condition no longer persists or, as shown here, the on signal is toggled low. Illustrated in this slide is a typical normal turn-on operation of Silego IPSs. Because of an internal ramp control circuit, the observed output voltage is monotonic and linear. For more information on Silego's world-class, high-performance integrated power switches, or to speak to an applications engineer, please visit our homepage at the top of your screen. From there, you can also read or download our product selector guides and application notes. Thank you for your interest in Silego's HFET IPS products.